Okay, does it seem like I just did one of these? Because I feel like I just did one of these. But now I'm doing another one. I'm super tired. I woke up at 4 a.m. this morning to catch an airport shuttle to catch an early morning flight. So I've been up for a long time, and uh, hopefully I'm not too tired to make things work. Um, so let's add a folder for day 07, and let's add a file for day 07.py. And let's exit and IPython and cd day 07. And then I can close this, and then I can close this, and now I can go back, and the problem is available. Okay. I judge them by how long the writing is. The writing doesn't look too bad. Based on the navigational maps, you're gonna need to send more power to your ship's thrusters to reach Santa in time. And let me make sure I'm streaming correctly. To do this, you'll need to configure a series of amplifiers already installed on the ship. There are 5 amplifiers connected in series. Each one receives an input signal and produces an output signal. They are connected such that the first amplifier's output leads the second amplifier's input, second, so on, so on. The first is 0, and the last leads to the thrusters. They also sent you some amplifier control software, a program that should run on your existing Intcode computer. Each amplifier will need to run a copy of the program. Okay, see, this is why I refactored my Intcode computer. When a copy of the program starts running on an amplifier, it will first use an input instruction to ask the amplifier for its current phase setting, integer from 0 to 4. Each phase setting is used exactly once, but the elves can't remember which amplifier needs which phase setting. The program will then call another input instruction at the amplifier's input signal, compute the correct output signal, and supply it back to the amplifier with an output instruction. If the amplifier has not yet received an input signal, it waits until one arrives. Your job is to find the largest output signal that can be sent to the thrusters by trying every possible combination of phase settings on the amplifiers to make sure that memory is not shared or used between copies of the program. For example, suppose you want to try the phase setting sequence 31240, which means setting amplifier A to phase setting 3, amplifier B, and so on. From the output signal, you can set amplifier B with the following. Start the copy of amplifier, the starting A is first input instruction. Provide it the amplifier's phase setting 3. Add a second input instruction provided the input signal 0. After some calculations, it will use an output instruction. Start the output for amplifier B, provide the phase setting, then whatever output signal was produced for amplifier A, it will then produce blah blah blah, blah blah blah, blah blah. The final output signal is sent to the thrusters. If you see this one, another sequence, for example, max thruster signal from phase setting sequence. What is the highest signal that can be sent to the thrusters? Okay, so that sounds pretty reasonable. So let me just copy this. I know it's bad form to copy code like that, and I should just do it, but that's fine. And okay, so what do I want to do? I want to do the following. So I have named tuple. That's good. So class amplifier is a named tuple, and an amplifier is going to have a phase, which is an int, and it is going to have a program, which is a list of int. And everyone I think is going to have the same. And what did it say? I want to provided the input signal is 0. Is the input signal always 0? That's what I want to find. First input value is 0. Okay. So what I want to do is I want to run, let's say, amplifiers is a list of amplifier, and phases is a list of int, and it is going to give me an int as output. And I think I want to add a method to my amplifier. So what I want to do is I want to be able to run it with an input, which is an int. And I can do that by doing, well, there's already that run there. So I don't want to call it run. I'll call it run amplifier, which I don't like, but actually what I'll do is I'll change this to be called run program. And now I can do run self input int, and it's going to give me another int. So what it's saying is that my inputs should be input, it's a reserved word, and phase. Is that right, or did I get the order wrong? First input instruction provided the phase, at its second input provided the input signal. So let's go back and change that. So let me do input signal, and then inputs are going to be self.phase and input signal. And then what I want to do is I want to basically say out, it's going to produce more than one output by definition, but it's going to, the final output signal, it will use an output instruction. So it seems to be assuming that there's only going to be one output. So I'll just do like a little tuple unpacking, which is, it was run program of self.program and inputs, and then and so I'll just say return outputs. So that's that. So now if I want to run these amplifiers, what I want to do is for actually I don't even need these amplifiers. So let me, I'm changing this as I go. So I'm just going to call this run amplifier. It's going to be program is a list of ints and a phase, which is an int, and it's going to return an int. And run amplifier program input signal, which is an int, and a phase, which is an int. And I'm just going to say inputs equals self.phase input signal, output comma equals run program, and then return output. And so now I don't even need to keep track of these amplifiers. I can just say run with these phases, and let's say last output equals 0. And so for phase in phases, what I can do is I can say last output equals run amplifier, and I guess I need to give a program as well, which is a list of int. And the way I've set things up, when I call run program, it makes a copy of the program, so that's fine. So they won't step on each other. Equals run amplifier of program and phase, and then finally I return the last output. So now let's take their so assert that run of here's the program and here's the phases is 43210. And so what is it? That's what I mean when I'm tired. Say I'm tired. So let's run this now and see what happens and see if it works or not. Run amplifier, missing one required positional argument. Run the amplifier program, last output, and phase. Okay. Name error self is not defined because I made it into a function. Let's try one more time. Name self is not defined because I turned it into a function. And that worked. Let's add one more unit test. And then what were the phases? They were 0, 1, 2, 3, 4. And I won't do the next one if these two work, because that should be fine. Equals 5, 4, 3, 2, 1. Okay, good. So now what I want to do is find best phases. Best phases. And I want to find the best phases or the best output. What's the highest signal that can be sent to the thrusters? So what I want to do is I just want to say best output for program, which is a list of ints, and that's going to return an int, is for and I can get permutations from iter tools, right? I think iter tools is your best friend. For phases in iter tools dot permutations of well, let's try this out. For iter tools dot permutations of range 5, and just put a list around it. Yes, and I'm supposed to do 5 of them, right? There are 5 amplifiers in series, right? So, iter tools permutations range 5. And so I can just do max of run program phases for phases in this. And so now these were supposed to be the best outputs, right? So I can say assert best output of this guy equals 4, 3, 2, 1, 0. And I can assert that best output of this guy equals 5, 4, 3, 2, 1. So let's run that, and that passes too. So that seems good. And now let's get our puzzle input. Okay, so now program equals this, and print best output of program. So now let's run it, and it says it's this number. So let's do this and plug it in. Nope, I didn't copy it because, again, this is the stupid thing with having to do Control-Shift-C because it's a Linux terminal. Control-V, submit. That's the right answer. You're 1 gold star closer to rescuing Santa. Continue to part 2. It's no good. In this configuration, the amplifiers can't generate a large output signal process you need. Elfscope can talk you into through rewiring the amplifiers into a feedback loop. Most of the amplifiers are connected to the before, however, amplifiers A is connected to amplifier B's input and so on. However, the input from amplifier E is not connected to amplifier A's input. This creates the feedback loop. Signal will be sent through amplifiers many times. In feedback loop mode, amplifiers need totally different phase settings. Integers from 5 to 9, again, use exactly once. These settings will cause the amplifier controller software to repeatedly take input and produce output many times before halting. Provide each amplifier its phase setting and its first input instruction. All further input, output instructions are for signals. Don't restart the software on any amplifier during this process. Each one should continue receiving and sending signals until it halts. All signals sent or received in this process will be between pairs of amplifiers, except the very first signal and the last signal. To start the process, a 0 signal is sent to amplifier A's input exactly once. Eventually, the software and the amplifiers will halt after they have processed the final loop. This happens, the last output is your job is to find the largest output signal sent to the thrusters using the new phase settings and feedback loop arrangement. Here are some example programs. Max thruster signal. This from says so I'm not following when it stops. Program should run when it first uses an input instruction. So I didn't follow those instructions. So I do a feedback loop. Most connected as they were before. However, the output is now connected to the amplifiers A's input. This creates a feedback loop. Signal will be sent through the amplifiers many times. In feedback loop mode, the amplifiers need totally different phase settings. Integers from 5 to 9, again used exactly once. These settings will cause amplifier controller software to repeatedly take input and produce output many times before halting. Provide each amplifier its phase setting at its first input instruction. All further output instructions are for signals. Don't restart on any amplifier. Each one should continue receiving and sending signals until it halts. All signals sent or received in this process will be between pairs of amplifiers, except for the very first signal and the very last signal. To start the process, a 0 signal is sent to amplifier A's input exactly once. Eventually, the software on the amplifiers will halt after they have processed the final loop. When this happens, the last output signal from amplifier E is sent to the thrusters. So your job is to find the largest output symbol that can be sent to the thrusters using the new phase settings and feedback loop arrangement. So this is going to require some serious rewriting of what we've done, unfortunately. So let's make a new file for it. D07 part 2.py, and I'm still not entirely sure I understand it, but at the very least we'll and so here I'm going to need to change the way a program works, because here okay, so let's read this one more time. This is hard. No good. First connected to 4, blah blah blah. It's now connected to amplifier A's input. This creates feedback loop many times. In feedback loop mode, the totally different phase settings, 5.9. These settings will cause it to repeatedly take input and produce output many times before halting. Provide each amplifier its phase setting at its first input instruction. All further output instructions are for signals. Don't restart the amplifier controller software on the amplifier in this process. Each one should continue receiving and sending signals until it halts. Okay, so we're going to we're actually going to change this around quite a lot, and that's as follows. Now we need these programs so class amplifier, and we're going to init it with a program, which is a list of ints, and a phase, which is an int. And so we'll say self.program, and here we'll make a copy of the program, but we'll leave it around, and self.phase equals phase, and actually we don't even need the phase, we just need to self.run input value equals phase. Is that right? All further input output instructions don't restart until symbol sent will be sent between pairs. To start the process, a 0 price amplifier its phase setting at its first input instruction. Okay, so actually let me not do this. Self.phase equals phase, and self.phase sent equals false. And now what I can do is I can do def, I'll call this send input value, which is an int, and it's going to return an int, which is the output value. And let's just self.last output equals none. We'll see if that's worthwhile. And I just have this feeling this is not going to work. I have a feeling that the way I designed this computer is going to be wrong. And let me think about that a little bit harder. Like now, this kind of has to be a state machine. So like self.pause equals 0, and right. So now and self.inputs equals nothing. Although actually we want to do self.inputs equals phase, so I'll do that. And okay, so we have this amplifier, and it has a program, and it has a pause, and it has some inputs which start with the phase, and it has the last output. And so def, and let's just say step self input value, which is an int, and that's going to return I've forgotten how this thing works. Integers 99 means the program is finished and should immediately halt. Actually, so that's outputs the value of its only parameter. So let's just say it does an output. Okay, so first use the input instruction to ask the amplifier to return a case setting. Oh no, that's part 1. Okay. These settings will cause it to repeatedly take input and produce output many times before halting. For example, amplifier to phase setting at its first input instruction. All further input instructions are first signals. Don't restart the amplifier control software on an amplifier during this process. Each one should continue receiving and sending signals until it halts. All signals sent will be sent between pairs of amplifiers except for the very first signal and the very last signal. Start the process, a zero signal is sent to amplifiers A exactly once. Eventually, the software on the amplifiers will halt after they have processed the final loop. Oh, every day. I should look at this. People might be commenting about about how terrible I'm doing. So I'm trying to like reason through like what states need to happen here. So I have all these amplifiers, and now when I so they're still gonna run in order. So I think that's gonna be okay. Self.step phase, and then I think we can throw away that output and self.pause equals 0, and that will be fine. And so this will return an int, and so let's see if I can get this right. So first I will make this a method. Mode equals 0, return self.program pause. Otherwise, return self.program pause. So now I have this get value, and now I want to step with some input value and produce an output value. And what I want to do is the following. I think I still want this this whole thing, except that I'm going to do self.pause. Every one of these pauses is going to be now self.pause because I want that state to persist. And let me just copy this. And self.pause, self.pause. Otherwise, we'll store the input. And otherwise, we'll send the output. And I missed a bunch of these, but I see where the problem is going to come, and we'll see if I can fix that. And that's the following. Okay, so what I really want to do is if I want to end program, um, I'm actually going to return none, which is an abuse, but um, and if I get send to output, um, instead of doing this, again I missed self.pause. I missed a bunch of them. That's gonna kill me because it's gonna cause a terrible bug. Um, and then here I want to return the value. So um, so that two things happen. One is this loop keeps going until either I and here I don't need this return anymore because so when I take a step, what am I doing? I'm entering a while true loop, and I'm just going to say go through this and go until I either produce some output or end the program. So if I end the program, I'm going to return none. If I return uh, the output, then I return that value. But I'm leaving the position, where it would have been, so that when I come back, uh, I will be able to pick up where I left off. Um, so I think that's um, okay. And now, what do I need to do? Is I need to um, uh, and actually, I'm going to change this again. Self.phase equals phase, self.phase sent equals false. And then what I'm going to do is uh, input value. Um, and where am I using input values? I'm using uh, this input, which doesn't even exist. So um, if self.phase sent inputs equals input value, else inputs equals self.phase input value, and self.phase sent equals true. So it says I want to send that phase as the inputs before I do anything. And actually, let me change that as well. Self.inputs equals phase, and then I'll do it like that. And so what I'll do is I'll do self.inputs.append input value. Okay, and then I'll go back to if I want to store inputs, and again I'll do input value equals self.input 0, and then self.inputs equals self.inputs 1. So basically I'm just popping off actually, you know what? Let's be smart. Not that it makes a difference here, but this is the right way to do this, is to have a queue. Self.inputs is a double-ended queue that starts with the phase. And now what I can do is self.inputs.append. That's fine because it'll append to the right. But now what I do is self.inputs.pop left. So now I pop off the front of the queue, add inputs to the back of the queue, so that's fine. And So I think that's good. If this doesn't work, I might give up for the night because so I want to so now what do I want to do? And so def run amplifiers program, which is a list of ints, and phases, which is also a list of ints, and that's going to produce an int, which is an output. And so amplifiers equals amplifier program phase for phase in phases. So that's fine. And num finished equals 0. And and so what do I want to do? And I want to to start the process, a 0 signal is sent to amplifier A's input exactly once. So last output equals 0. And let's say amplifier ID equals 0. And while num finished is less than len amplifiers, so here's what I want to do. I want to say last output equals amplifiers. I'm just going to call this AID because amplifiers. And let's just say n equals len amplifiers. That's easier. While num finished is less than n. Last output equals amplifiers AID dot step last output. If last output is none, num finished plus equals 1. I don't know what happens if they finish at different times. That hopefully that doesn't happen because that would cause us a lot of grief. So we'll just assume that that doesn't happen. And now amplifier ID equals amplifier ID plus 1, and then we want to mod it by n so that we go back to the start, and then we want to return the last output. So let's try one of theirs. So let's say that prog1 equals this, and phases1 equals this. I'll be sort of surprised if this works. Assert that run amplifiers prog1 phases1 equals this thing. Whoa, that's really surprising. I'm incredibly surprised. Okay, let's try one more. Prog2 equals this. Phases2 equals, what is the phases2? Wow, I'm really surprised. This assert run amplifiers prog2 phases2 equals, and what's that supposed to be? 18216. So now name program is not defined. You know what? I think I didn't save it last time, and that's why it passed. That's not funny. Well, true. Because it didn't do anything. Okay. Oh God, every program needs to be a self.program. Yeah, that definitely didn't pass. So let's start making these go. I can't just replace program with self.program because that would replace with self.program. So let's do that, and then I've got some self.selfs. Let's just replace those with selves and replace those. And now let's try it again and see what goes wrong. Syntax error. Yeah, right. That's what happens when you do a global find and replace. I didn't want to replace every name and self. Damn it. Stupid find and replace, and I bet that happens again down here. This is how the sausage gets made. Name self is not defined. Oh, it screwed up. This is making me so frustrated. Amplifier object has no. I thought I got rid of all the self.self. Get value is not defined. Okay, let's see if I have any better luck with this one. I do not. All right. So let's comment this one out so we have one of them. And let's see what's happening. Print AID last output, and let's just see what happens here. 00150129. Okay, so it's doing something, and let's print num finished. None of them have finished. So now, when I get back to amplifier ID 0, print self.inputs, opcode, modes, and I'll do self.pause as well. Because it looks like it works on the first pass through, so like that's promising in some ways, but it gets in an infinite loop. And why does it get in an infinite loop? And why does this not give me any scroll back? So let me go here, cd day 07, run Seriously. Okay. So program is 22. The input is 129. Jump if true. Let's print out this jump if true. Print value 1, value 2. And let's see. It's saying, that's the issue. I I told you I was going to miss some of these self-dot pauses, and indeed I did. So let me do a regex search and do I don't want let's try a regex search here. Okay, let me do a space pause. Okay, so I fixed that problem. Now let's try it, and well, that's better, I guess, in that it didn't get an infinite loop. It's worse in that it gave me the wrong answer. Um, um, and part of the problem is that if I got a none, then last non-none output equals none. So else last non-none output equals no. That's not right. Yeah, it is. Last non-none output equals last output. And now let's return last non-none output. Hey, so once I made that change, it worked actually. So that's good. And that worked too. Okay, good. So now this seems to be working correctly, if a little bit verbosely, but that's fine. So now we want to do basically the same thing. Output maximum, except now we want the permutations of, I think it's 5, 6, 7, 8, 9. Is that right? 5, 6, 7, 8, 9. So we want permutations of that. And now, what is the highest? And so again, I need to copy. Is that the actual program? Did I really call it that even with the, yeah, I did. All right. Program equals that, and print. Actually, let me add in another unit test that basically just to make sure this is right. Assert best output of prog1 equals, this guy and assert that best output of prog2 equals this guy. So now let's name run is not defined, and that's because I called it run amplifiers. Okay, so that worked, but I don't want to do all these printing, so I'm going to comment those out. Now let's run it again, and it took a little bit of time, but that's fine. And so now print best output of program, and let's see if this works. Oh, that was fast. Control Shift C, and let's. Hey, that's the right answer. One gold star close rescuing Santa. Okay, so that one was one of the bad ones, and you can see it's a bad one. It took me almost an hour to do it, but I did do it. But I'm not that happy about it. Anyway, I'm happy that I finished it, but I'm not happy about how it went or how difficult it was. So, thank you to thank you to everyone for watching this. And yeah, so hopefully tomorrow is easier. Thanks for watching.